The threshold of the observable universe has remained a mystery for hundreds of years, generating interest and hypotheses among scientists and enthusiasts. However, the James Webb Space Telescope is the key to uncovering this cosmic mystery. With its powerful lenses that peer deeper into space, it recently made a stunning announcement about the edges of the observable universe. To understand the limit of the universe, it is important to understand the concept of the observable universe, which includes everything we can see, measure, and study from the ground or with our telescopes and probes in space. Currently, this includes stars, galaxies, and other celestial bodies within our range of observation. The observable universe is only a small part of the entire universe that we can observe and understand. The size and shape of the entire universe is unknown, but the observed universe is estimated at about 93 billion light-years. A light-year, the distance light travels in 1 year, is approximately 5.88 trillion miles, 9.46 trillion kilometers. Thus, the observable universe extends to an immeasurable width of approximately 5,468 billion miles, 8,784.04 billion kilometers, in diameter. About 13.8 billion years ago, the universe was born in a powerful explosion known as the Big Bang. This event caused a rapid expansion, and since then the universe has been expanding faster and faster, driven by mysterious forces such as dark energy. While the universe expanded, particles of matter began to unite under the influence of gravity to form structures like stars, galaxies, and eventually planets like the Earth. Despite the vastness of the universe, it is mostly empty. If our entire solar system shrunk to a quarter of the size, the nearest star would still be 2 football fields away. It is only in our Milky Way galaxy, one of billions in the observable universe. The idea of the limit of the universe is puzzling and has long fascinated scientists, philosophers, and thinkers. There are various theories about what lies beyond, but the truth remains elusive. 3 main theories stand out. The universe goes on forever without end, it is finite but has no clear edge, and the multiverse principle suggests that our universe is just one of many parallel universes. The James Webb Space Telescope allows us to look far back in time and discover unexpected objects in the early days of space. Its advanced features allowed astronomers to see back into the early universe. In a recent study published in the journal Nature, the James Webb Space Telescope discovered 6 large galaxies that existed between 500 and 700 million years after the Big Bang. Scientists expected to find small, newly formed galaxies, but the telescope surprised them with much larger galaxies than expected, challenging our understanding of the early cosmos. These massive galaxies, nicknamed universe breakers, defy 99% of early galaxy models. We used to think that galaxies start out as small clouds of stars and dust that gradually grow over time. Universe breakers proved us wrong. When the telescope's high-resolution images became available in July 2022, scientists were struck by the appearance of these galaxies as massive point sources of light, almost as if they wanted to see them. By using spectroscopic techniques to study light at different wavelengths, scientists can reveal valuable information about these galaxies, including their composition, size, and distance from Earth. A phenomenon at the edge of the observable universe continues to capture our imaginations and drive scientific research. The James Webb Space Telescope is poised to reveal even more secrets of the cosmos, changing our understanding of the universe and our place in it. It exceeded all expectations and developed faster than expected. Some of the objects detected using this data may be completely different than expected. While most of these are likely galaxies, it is possible that some may be hidden supermassive black holes. The known mass of stars in the universe is now believed to be up to 100 times greater than previously thought. An impressive discovery. An international team of astronomers using the James Webb Space Telescope made an extraordinary discovery. The oldest and most distant galaxies ever confirmed take us back to a time when the universe was a fraction of its current age, less than 400 million years old. Years after the Big Bang, the light from these galaxies reached us more than 13.4 billion years ago. Using precise spectroscopic observations, astronomers confirmed 4 of these objects, allowing them to study the physical properties of the galaxies and accurately determine their distances. To determine the distance of a galaxy, astronomers calculate its redshift. Estimates of redshift can be derived from images taken through various filters, but spectroscopy is better for precise measurements because it divides an object's light into wavelengths. The new findings focus on 4 galaxies with redshifts greater than 10, indicating that they are very distant. 2 of these galaxies were previously observed by the Hubble Space Telescope at redshifts of 10.38 and 11.58. However, images from the James Webb Space Telescope revealed even more distant galaxies at redshifts of 13.18, 20, and 12.63, dating back to about 13.5 billion years ago, revealing an ancient cosmic history. The James Webb Space Telescope Advanced Deep Extragalactic Survey, JADES, is an ambitious program that aims to provide an unprecedentedly deep glimpse into the early cosmos. Starting with the Near-Infrared Camera, NIRCam, the JADES program dedicated more than 10 days to observing a small region of the sky, including the Hubble Ultra Deep Field. Probing at 9 different infrared wavelengths, the JADES team found nearly 100,000 extremely distant galaxies, each billions of light-years away. Using the Near-Infrared Spectrograph, NIRSpec, the researchers collected light from 250 faint galaxies during a 3-day observation period, revealing the gas and stellar properties of these galaxies and obtaining precise redshift values. These measurements allow astronomers to determine the intrinsic brightness of galaxies and estimate the number of stars they contain. Understanding the early generations of stars and galaxies can be as difficult as understanding humans. The influence of early generations of stars on the future of galaxies is similar to how early experiences shape our lives. This is an incredible time in history as the transformative capabilities of the James Webb Space Telescope answer many questions about galaxies. NASA's Deep Space Observatory Telescope is revolutionizing our understanding of space and revealing a treasure trove of new discoveries. Released in December 2021, Webb, which is expected to operate for 2 decades, is just beginning its space journey. Exceeding the standards set by its predecessor, the Hubble Space Telescope, Webb captured the imagination of scientists and the public alike, inspiring a wave of scientific enthusiasm. People around the world are eager to improve the telescope's raw data, share its stunning images, and gain new views. After a flawless deployment process, Webb stunned us with its first images in mid-July, giving us unprecedented insight into countless parts of our universe. Using an advanced infrared telescope, the James Webb Space Telescope will allow us to study the most distant galaxies in an extraordinary way and look deep into the past. Within days of going online in late June 2022, its powerful instruments began to reveal hundreds of previously unknown galaxies that are older and more distant than ever imagined.
The telescope's capabilities allow scientists to collect vast amounts of light from celestial objects, including exoplanets and newborn stars, to reveal their composition and track their trajectories through space. This wealth of information is already revealing intricate details about the composition of the atmospheres of planets hundreds of light-years away from Earth, suggesting their possible habitability. Additionally, the James Webb Space Telescope identified what is possibly the oldest black hole ever discovered by analyzing faint light signatures in the universe's infancy. This supermassive black hole, millions of times the mass of the Sun, is at the center of a young galaxy that was formed 570 million years after the beginning of the universe. Thanks to Webb's powerful cameras, which can look back in time to the earliest moments of the cosmos, this monumental discovery offers glimpses of the cosmic dawn. Although black holes proliferated a billion years after the Big Bang, the origin and distribution of these enigmatic cosmic creatures are still mysteries that baffle astronomers. The James Webb Space Telescope's exploration goes beyond merely identifying distant galaxies and black holes. It provides a unique window into the processes that shaped the early universe. By observing the chemical compositions and structures of these ancient galaxies, astronomers gain insights into the conditions that prevailed during the universe's formative years. This, in turn, helps us understand how galaxies, stars, and planetary systems, including our own, came into existence. The telescope's ability to detect faint infrared light allows it to peer through cosmic dust and gas clouds that obscure many celestial objects from our view, revealing hidden details and mechanisms driving the evolution of the universe. In addition to deep space exploration, The James Webb Space Telescope is poised to revolutionize our understanding of exoplanets, planets orbiting stars outside our solar system. With its advanced instruments, the telescope can analyze the atmospheres of these distant worlds, searching for signs of habitability and even potential biosignatures. By studying the light that passes through an exoplanet's atmosphere, scientists can detect the presence of molecules such as water, carbon dioxide, and methane, which are essential for life as we know it. This capability not only broadens our knowledge of planetary systems across the galaxy, but also brings us closer to answering the profound question of whether life exists elsewhere in the universe. The James Webb Space Telescope stands as a testament to human curiosity and ingenuity, pushing the boundaries of our cosmic understanding and opening new frontiers for exploration and discovery.